Welcome, folks. We're going to be starting our new unit today, which is on combinatorics. Combinatorics deals with different ways to count things, essentially. That's what combinatorics means, is it's a field of mathematics dedicated to counting things. And so we'll cover a variety of different principles for counting. Today, our lesson is going to focus on the fundamental counting principles. The fundamental counting principle. Why do we need to understand counting principles is a question you might be asking. Well, the reason why is because probability is sort of built on, at least theoretical probability, is sort of built on this hypothesis that if we can count the number of possible outcomes of a given event, and if we can count the number of the number of outcomes in the sample space, then we can determine the probability of that event. Now, up to this point, we've been dealing with situations where counting the number of possible outcomes has been really easy, and counting the number of outcomes in the sample space has also been easy. Going forward, we're going to deal with situations where that's more difficult to do, and so we're going to have to rely on counting principles to count the number of possible outcomes in various situations. Okay, so let's talk about our first counting principle. It's called the fundamental counting principle. And the fundamental counting principle says that if an experiment has A possible outcomes and another independent experiment has B possible outcomes, then there will be A times B possible outcomes when both experiments are run. Okay. Now, this only works when the experiments are independent of one another, which is the only kinds of experiments that we're dealing with in this unit. Reminder that things are independent if the occurrence of one doesn't affect the occurrence of the other. So we'll see some examples of that coming up here. So here's our first example. Consider the possible outcomes when flipping a coin and rolling a six-sided die. So we're going to make a tree diagram here to kind of talk about the outcomes of flipping the coin and rolling a die. So for the coin, we know that can come up heads or tails. And the dice can come up 1, 2, 3, 4, 5, or 6. So we could get a heads with a 1, 2, 3, 4, 5, or 6, or we could get a tails with a 1, 2, 3, 4, 5, or 6. So now I'm going to list out those 6 outcomes. So we could get a heads and a 1, a heads and a 2, a heads and a 3, heads and a 4, heads and a 5, heads and a 6, or we can get a tails with a 1 through 6. And so if you count up those outcomes, you can count that adds up to 12. But we could also calculate this with the fundamental counting principle. There's 2 possible outcomes for the coin. There's 6 possible outcomes for the die. And 2 times 6 equals 12. Okay, so hopefully that makes sense. Let's move on to another example. Consider the possible outcomes when flipping 3 coins. So your first toss, the coin could come up heads or tails. Same thing with the second toss, could come up heads or tails. And same thing with the third toss, it could come up heads or tails. So if we look at our outcomes, we could get heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. If we count those outcomes, that adds up to 8, but we could also do this with the fundamental counting principle. So we could say 2 times 2 times 2 And I want you to recognize that this is the same thing as 2 to the third power equals 8. All right, example 3. Whitney went to a deli. Right now the deli has a deal where they will sell a sandwich with 1 kind of bread, 1 kind of meat, and 1 kind of cheese for $3. The deli has 2 kinds of bread, sourdough and wheat. The deli has 4 kinds of meat, ham, turkey, beef, and salami. The deli has 3 kinds of cheese, American cheddar and Swiss. List out all of the possible sandwiches she could order, then use the fundamental counting principle to ensure that you got all of the combinations. We're going to list out all the possible combinations. And so let's start with just one combination. I'm just going to take the first item from the kinds of bread, which is sourdough, the first item from the kinds of meat, which is ham, and the first item in the list from the kinds of cheese, which is American. So sourdough, ham, American. And so you can imagine in each box here I'm going to vary the kind of cheese. So it could be sourdough ham and cheddar, or sourdough ham and Swiss. Now in my next set of boxes, I'm going to vary the meat. So now I've taken each one of these combos here, so like for example, sourdough, ham, and American, and as we go across to the right here, I'm changing it from sourdough, ham, and American to sourdough, turkey, and American, sourdough, beef, and American, sourdough, salami, and American. Okay. And then now in these 4 boxes below, I'm changing all these S's to W's to count all the combinations of wheat. So when we do that, we can see that there's 3 in each box. We've got 8 boxes. 3 times 8 is 24. We could also count this using the fundamental counting principle. So 2 times 4 times 3. And that equals 24. Okay, one last example. Sydney's trying to create a schedule for her first year as a college student. She must take 1 math, 1 social studies, English and science course. Her university offers 3 different math courses for a freshman: algebra, pre-calculus, and calculus. Her university offers 2 different social studies courses for freshmen: world history and human geography. Her university offers 2 different English courses for freshmen: composition and literature. Her university offers 3 different science courses for freshmen: physics, chemistry, and biology. List out all of the possible combinations of courses she could take, and then use the fundamental counting principle to ensure that you got all the combinations. So, again, I'm just starting with the first item in each list. So we've got algebra, world history, composition, and physics. So then algebra, world history, composition, and chemistry. Algebra, world history, composition, and biology. Okay, so now in the next box, now I'm varying the second letter, right? Because she could do composition or literature course for her English course. Now for the next 2 boxes, I'll be varying the second one. So we can see that that can be world history or human geography. So I've taken my first 2 boxes and I've just varied them so that the W's are all H's. And then there's 3 different courses, options for math courses. So she could do algebra, she could do pre-calculus, or she could do calculus. So making use of your lasso tool and copying and pasting will really cut down on the amount of work that you have to do here, right? Because once you make one combination, In this first box, you can just copy it and paste it twice and then just change the last letter. You can copy and paste this over to this box and change the second letter. Then you could copy these two boxes, paste it over here, change your second letter, and then you could copy these 4 boxes and paste them here, change the first letter to a P, and paste them here and change your first letter to a C. So just a suggestion to make this less work. Okay, and then of course we can verify this answer with the fundamental counting principle. So 3 times 2 times 2 times 3 is 36, and if you count up, we have 12 boxes here, each with 3 different combinations here. And so that will, 3 times 12 is 36. Okay, let me know if you have any questions.